Section 12.3 is the last section of calculus that we'll be doing. And this is kind of the big use for calculus for us is going to be these optimization applications. So optimize, optimum means best, and it depends on the context of what is best. So if you're talking about revenue or profit, higher is better. So you would want to maximize. But if you're talking about cost, lower is better. And you would want to minimize. So you just have to read each question and figure out whether you're trying to find a maximum or minimum. So to begin the conversation, we're going to talk about a theorem called the extreme value theorem. And what this gives us is the guarantee that if a function's continuous and we're on a closed interval, then the function has guaranteed both an absolute max and an absolute min. So the procedure for answering this sort of question is to find the first derivative. So we'll have 4x cubed minus 36x. Set that equal to 0 to find any critical values. And I see a GCF of 4x, so I'm going to factor that out. And then I see that I can factor more, a difference of squares. So then I can use my zero product property and say either 4x is 0, x plus 3 is 0, or x minus 3 is 0. And that's going to give me my three critical values of 0, -3, and 3. And then I just check to make sure that these are all in my closed interval of -4 to 4. So if -4 is here on the number line and 4 is here, my critical values are -3, 0, and 3. So they are all on my interval, so I need all of them. So then what you do is list your critical values, 0, -3, and 3, and your endpoints of your interval. And then you evaluate the original function for each of these x values. So f of 0 is going to be easy. Put zeros in for all the x's, and all that's left is the 1. Then if we do f of -3, it will be -3 to the 4th power minus 18 times -3 squared plus 1. Well, I want you to notice something about, what about when I put +3 into this particular function? And notice that the values are going to be exactly the same because of the even exponents. So you can save yourself some work. So for the first f of -3, I get -80, but I know that has to be the same value for f of 3, because -3 to the 4th, same number as 3 to the 4th. So that same thing is going to happen when I put -4 and then 4 into the function because of that even exponent. And I'm getting -31. So now you look at all these y values and you just look for the highest one, the one most to the right on the number line. So here it is, 1 is the largest number I see. So f has an absolute max value of 1, and it occurs when x equals 0. Okay, then we look for the smallest or lowest y value, and we see that it's at -80. So f has an absolute min value of -80. It occurs when x equals -3 and when x equals 3. So it actually occurs at 2 places. Okay, so that's the procedure. Find the derivative, the first derivative, set it equal to 0. Find any critical values. Make a list of the critical values and add to that list the endpoints of your closed interval. Calculate the function's value at each of those points. Look for the biggest number, that's your absolute max. Look for the smallest number, that's your absolute min. Okay, so that's if you're on a closed interval. So that's a requirement for the extreme value theorem. If you have an open interval, there may or may not be absolute extreme values of the function. So that's what this next example is going to illustrate. So with this critical point theorem, we're still going to find critical points because those are going to be important possible change points. So I'm going to find the first derivative, 3x squared minus 4x minus 4. Set that equal to 0 and look for critical numbers. So I'm going to have 3x and x, and 2 and 2. Make sure that works, looks good. So then we use our zero product principle to say either 3x plus 2 equals 0 or x minus 2 equals 0. So my critical values are x equals -2/3 and 2. Well, I'm being asked about the interval from 0 to infinity. So x equals -2/3 is not in this interval. So I don't even need to consider it. Okay, so let's make a number line and think about what's going on here. So we only have x values from 0 up, and we do have a critical value at 2. So label this row of your chart x values. Then the next row is going to be f prime values. So at x equals 2, f prime is 0. And then we want to know what happens to the left and to the right. So let's pick a point between 0 and 2. And see what's happening. So we're going to pick a point. Let's pick 1 and say, what is f prime doing? Is it positive or negative? So f prime of 1 is going to be 3 minus 4 minus 4. So that's negative. So in that interval from 0 to 2, the first derivative is negative. Okay, then let's look at the interval from 2 to infinity and test, say, 10, because that will be easy to tell whether it's positive or negative. And that's clearly positive. So there's never any other critical numbers to the right. So the first derivative never changes anymore as x gets larger and larger. So let's see what that tells us about our function. So our function is decreasing, then it gets to a local min and then increases. So whatever our function is doing, it's coming down to a local min, and then it's increasing everywhere after that. So there's no absolute max. There isn't going to be one. And then the absolute min is going to happen at the same point as the local min when x is 2. So f of 2 is going to be 2 cubed minus 2 times 2 squared minus 4 times 2 plus 1. And that's -7. So that's going to be our absolute min value of f. So it has no absolute max because it keeps going up, increasing more and more and more. Okay, so the most challenging problems in this section are usually the optimization problems. And there's some suggestions here. This list is from your textbook. And let me strongly recommend reading the problem carefully, and in fact, read it more than one time. It often takes 2 or 3 or even more readings through a problem to have a clear mental picture of what's going on. Then sketch a diagram. So I require that, and my instruction set usually says draw a correctly labeled sketch. So you need to put labels on the parts of the sketch. Then you need to figure out what you're trying to maximize or minimize and what other information you're given. So let's look at this example. And actually, I think I'm going to shorten this video and put all the examples on the next video. So let me do that.